Let us discuss the Mobile Application Security Verification Standard, or the MASVS. The OWASP Top 10 list, which as its name implies, is a list of the top 10 security issues related to mobile applications. It's something that we frequently hear of when discussing mobile application security. Experienced programmers, testers, believe that this list is somehow insufficient. Why? Because it's a crowdsourced list of vulnerability categories rather than like a guide or a manual. There are currently as well no plans to update the list, which was recently updated a few years back. In order to design applications, developers would like a complete set of standards. Security testers would also prefer to use preset procedures to test an application against a set of objectives. We can take a look into the OWASP to satisfy these needs. However, MASVS is the right way to go. MASVS is an application standard for mobile application security. It helps developers to develop secure mobile applications. Testers can use the standards to highlight relevant security issues and risks. This standards provides a list of the requirements an application should adhere to. It defines mainly two security levels: MASVS Level 1 and Level 2. Level 1 contains generic security requirements that are recommended for all the applications. However, Level 2 contains requirements for defense in depth. We also have MASVS-R, which is mainly has to do with reverse engineering, which is useful actually for providing client-side defenses. MASVS Level 1 is termed as standard security. It adheres to mobile security general best practices and fulfills basic requirements in terms of code quality, handling sensitive data, and interaction with mobile operating system. However, Level 2 is termed as a defense in depth, as we just mentioned. To fulfill the Level 2 requirements, a threat model must exist, and security should be part of the application lifecycle. For example, a separate secure lifecycle has to be defined for sensitive data. 2FA should be enforced mandatorily. Certificate pinning is enforced as well. The Level 2 has a considerably high development overhead. Such requirements are usually applicable to financial and healthcare applications, which usually require certain compliance with PCI DSS, HIPAA, or other standards. MSTG, or Mobile Security Testing Guideline, is a comprehensive manual that can be used to test if an application fulfills the requirements outlined in MASVS. Likewise, developers can use the manual to get an idea of how the application can be hacked. Currently, the verification requirements are segregated into 8 types. They are architecture design and threat modeling requirement to resilience requirements. Let us go over each of these requirements individually. V1 is mainly about the steps that needs to be taken into account at every stage of development. In practice, security is frequently taken into account only at the end of the software development lifecycle. When establishing the architecture of a mobile application, MASVS mandates that certain procedures be in place to guarantee that security has been taken into consideration across all the stages. And here you can see a sample checklist on the description of each control objective and whether it applies to level 1 or level 2. A major focus of mobile security is the protection of sensitive data, such as user credentials and private information. If OS techniques like IPC or inter-process connection are handled incorrectly, sensitive data may unintentionally be exposed to other applications operating on the same device. Additionally, inadvertent data leaks to backups, cloud storage, or even keyboard cache are possible. Sensitive data can be classified into PII data, such as social security number, credit card number, bank account, healthcare information that can be exploited for identity theft. Highly sensitive information as well could damage companies' brands or cause financial loss. The remaining information that needs to be protected is any information that is required to be protected by law or a certain compliance framework. When it comes to safeguarding data saved on mobile device, cryptography is a crucial component. The controls are here to make sure that verified applications use cryptography in accordance with accepted industry standards. These standards include using trusted cryptographic libraries, appropriately selecting and configuring cryptographic primitives, and whenever randomness is required, using an appropriate random number generator. User login to a remote service is typically an essential component of the entire mobile app architecture. Even though the majority of the logic is executed at the endpoint, MASVS specifies some fundamental guidelines for the administration of user accounts and sessions. Without having access to the service endpoint source code, of course, it is simply to verify the requirements. The goal of V5 control is to guarantee the integrity and confidentiality of data transferred between the remote service endpoint and the mobile app. At the absolute least, a mobile app must configure the TLS protocol with the proper settings to create a safe, encrypted channel for network connection. Additional defense in-depth measures, including SSL pinning, are needed for level 2 or higher. V6 control ensures that the application uses platform APIs and standard components in a secure manner. Additionally, the control covers communication between apps or the IPC. The goal of V7 is to ensure that basic security coding practices are followed in developing the app, and that free security features offered by the compiler are activated. The MASVSR is specially defined level for defense against client-side attacks. That includes attacks like tampering, modifying, and reverse engineering. As such, an application should detect rooted, jailbroken devices, prevent debugging, detect application and asset tampering, verify client integrity, identify popular dynamic analysis tools such as FRIDA, have multiple strategies to achieve the points above, and of course employ device fingerprinting, impede static analysis by encryption and obfuscation, and have solid hardened communication strategies. This control do not universally apply to all mobile applications. Instead, depending on an evaluation of the risk posed by unauthorized modification, and or reverse engineering of the application. The safeguards outlined previously in the previous list and here in this checklist should be implemented as needed.